Dear students, let's start with the topic of thermal expansion. Thermal expansion is basically expansion of substances due to rise in temperature. In this whole section, we are going to study whenever temperature of a substance increases, it expands. And step by step, we are going to analyze how the expansion takes place, and we are going to also discuss the whole analytical part of thermal expansion. And the very first thing in this section we are going to study is thermal agitation. So many of you might be aware about what do we mean by thermal agitation. It is basically the randomized oscillatory motion due to a specified temperature in a substance. Say we are having a solid structure, say there is any solid. We know well that in case of a solid, its molecules are arranged in a specified fashion we call lattice, and the structure is called lattice structure. At every temperature, the particles of the solid, the molecules are having some sort of random oscillatory motion in the neighborhood of their local position, like this. Particles are in continuous oscillatory motion. And if we increase the temperature, the oscillatory motion will increase and they may start colliding with each other also. So we can say thermal oscillation is a random oscillatory motion of particles of a substance in the local neighborhood of their position. And when we talk about agitation energy, this thermal agitation energy is measured as proportional to the temperature of substance. That means if we increase the temperature of substance, the energy of the random oscillation will also increase. This is generally a qualitative term. Mathematically, we are going to discuss in detail in coming topics. But at this level, you must be aware about qualitatively that due to temperature, every particle of a substance has some random oscillatory motion in their neighborhood, and this random oscillatory motion is called thermal agitation. And when some heat is supplied to the substance, two different phenomena are there which can take place. You might have covered in early classes also. If we are having a substance and we supply thermal energy to it, say we supply heat to the substance, then two different phenomena can take place. The very first is rise in temperature and the other is change in phase. If we supply the heat to a substance, either its temperature will increase or its phase will change. That means a solid can melt down to a liquid, or a liquid can vaporize to vapors or in gaseous state. In this situation, we can state whenever heat is supplied and a substance gets some rise in temperature, then due to continuous thermal agitation, the substance will expand, which we call thermal expansion. Let's discuss how this thermal expansion takes place due to rise in temperature in a systematic way. Now, let's discuss step by step how thermal expansion takes place. Say we are having a physical substance and we supply heat to it, and we consider that due to supply of heat, its temperature increases. Now, say its temperature increases. So, we know well that the increase in temperature implies thermal agitation energy will increase, as we have studied that thermal agitation energy is directly proportional to the temperature. So, if temperature is increased, thermal agitation will increase. Thermal agitation implies random oscillations which are always there at every temperature. These will also increase. And if random oscillation increases, the particles will start colliding with the neighboring particles randomly. And on increasing temperature, we can say interparticle collision will increase in the substance. In the substance, you can state intra or intraparticle collision, the particles which are colliding with their neighbors, that will increase. So, due to continuous collisions between the particles of substance, we can say intraparticle stress will increase. The particle will start exerting stress on each other. So, we can say intraparticle stress increases. Thus, the stress in the substance which is due to the continuous collision of particles onto each other. And if particles are exerting stress on each other, we can say separation between particles increase. And obviously, if separation between particles of substance is increasing, that will change the dimensions, or we can say dimensions of substance. Obviously, in all dimensions of substances like length, area, or volume increases. And if dimension is increasing, this implies this is the phenomena of thermal expansion. So, when heat is supplied and it will increase the temperature, this temperature will increase the thermal agitation energy, and due to increase in agitation, oscillation will increase, particles will start colliding with each other, collision rate will increase, due to which the particles will start exerting stress on each other. So, due to increase in stress, the separation between particles will increase. So, because of which dimensions changes, obviously it increases, which we call thermal expansion.